Hi all, Padicky here. Today I'm going to cover 6 major topics you should know before diving deeper into .NET Core. The first topic is the .NET command line interface. Next up is the .NET Core languages. After that, we'll talk about the compiler, common intermediate language, common language runtime, and supported flat platforms, which are all closely related. Finally, we'll discuss the rich .NET ecosystem and why it's so valuable to you. This video is aimed mostly at beginners, but I know that .NET developers with some experience may also gain from the information, especially if they're newer to .NET Core. This introduction video is current as of .NET Core 3.1. With that out of the way, let's get to it. Our first major topic is the .NET CLI. The .NET CLI is a command line interface used to interact with .NET Core. It serves as a cross-platform toolchain for developing, building, running, and publishing .NET Core applications. You can use it to scaffold new applications, build or run existing applications, and it acts as the main entry point for operating systems on any platform. You will universally use certain commands like .NET Run to start applications. As you can see here, it errors out because I currently don't have a project open in this particular folder. When running an application on any platform, you'll universally use certain commands like .NET Run, like the one we just used. Likewise, the CLI can universally be used to restore dependencies with the command .NET Restore, which will happen automatically also when you do .NET Build, which builds your application, in addition to some other commands which we'll cover in a more in-depth video on the .NET CLI. These common universal commands work across all supported platforms, which we'll discuss more in depth later. What matters most here is the CLI is one of the first things you'll encounter while developing .NET Core applications, starting immediately after you've installed the .NET Core SDK. The CLI is a complex topic justifying a series of videos, most likely, or at least a single longer video, talking about all of the things the .NET CLI can do, from basics to advanced. And a link to the official overview for more information will be included in this video's description. At the top of the .NET Core stack is its language. The primary languages for .NET are C#, F#, and Visual Basic. C# is the primary language for .NET Core and the one that I will focus on in this channel. F# is a functional language for .NET, and Visual Basic is a more approachable, object-oriented language, very closely related to C#. We may or may not come back to Visual Basic, but our primary focus here is C#. As you can see from this shot, we're creating a new project in Visual Studio, and there's a series of different options. The ones that relate to .NET Core start with C#, move on to Visual Basic next, and then lastly, at the very bottom of that list, you can see F# console app for .NET Core. Again, like I said, we'll be focused on C# and C# technologies going forward, but these are all options for you to use within the .NET Core ecosystem. C# is a general-purpose, strongly typed, object-oriented language. It is most frequently compared to Java, but it can also be loosely compared to C++, C, or any other object-oriented language. C# was created in 2000 for use with the .NET framework, as you can see from the 2 options in this list. C# has evolved a lot since then, with the upcoming release of C# 9, and it is still one of the most widely used modern programming languages and still growing in adoption. Its most distinctive features are that it is a strongly typed language, that its classes derive from system.object, its use of reusable methods, class properties, polymorphism, and link, which we'll talk about next. Being strongly typed means that C# will warn you about variables being of the wrong type, and that users of this language must pay close attention to types. This is in contrast to other languages like JavaScript and others that don't require you to pay as close attention to types, which is why they created a superset of functionality for JavaScript called TypeScript. In this particular example, you can see I've created a number, which is an int type, and tried to assign a string to it, and you'll see that the compiler tells me with an error I can't actually do this. It prevents a lot of bugs being introduced into programs unnecessarily or by accident. This is great for C# developers, but can be a pain, and you'll learn to get along with it as you go. All classes in C# derive from the system.object class, which provides universal basic properties and methods for all classes. This means that C# developers can rely on a consistent set of properties and methods on all classes, regardless on when it was created, by whom, and for what purpose. So these base properties and methods are always available no matter what. In this code example, you'll see I create a string test with the value string. This is a very simple example of exactly what I'm talking about and uses a more advanced concept called pattern matching, which we'll get to later. But if I run this application, which essentially does a check and verifies that test actually is an object, even though I've assigned it as a string, we can run this and verify that it is in fact an object. Test is an object. So you can see I've created it as a string, I've assigned it a value, and it still is an object. This proves that all objects and all classes within C# are actually derived from system.objects. Properties are members of classes that contain a pair of methods, a getter and a setter, on an attribute of a class. Properties are extremely useful and deserves its own video, and you'll learn a lot more about properties while covering other topics. In this particular example, I've created one property called name, and it has a getter and a setter that's default. This means that in this code here, I can set the name of the lion, and then in console.writeLine, I can use the getter to get the name from the lion. And when I run this, it essentially just prints the name of the lion, which is, in this case, Simba. Just like that. Polymorphism is the ability to treat a single object as belonging to different types. An oversimplified and common example is a lion is a type of cat, and so is a tiger. In this way, the C# language allows you to classify different types as belonging to the same parent type with common functionality. For example, you could write a method to trigger growl for any type of cat, making the method a lot more reusable than having to write a different method for each of the more specific types. The most important limitation to consider in C# is that classes can only inherit from one other class, but it can implement an infinite number of interfaces. We'll talk a lot more about polymorphism, inheritance, and interfaces in other videos. In this particular example, I'm going to use a cat, which contains name, which used to belong to lion, and growl method, which is shared between all cats. In the actual main method itself, I call growl for both types, and the compiler doesn't complain about this at all. I've created a lion and a tiger, and assigned them both to cat objects, and both are allowed to growl with their names attached. Even though they're different types, I'm still allowed to use the same common growl for both types. LINQ, short for Language Integrated Query, is a feature of C# that allows developers to quickly and easily access and manipulate collections, for example a list, of objects. LINQ is a very deep topic, and we'll talk about it a lot more in other videos, but for now, you can see example LINQ queries that can be expressed using either extension methods or using query syntax. Extension methods are newer and more common, as in this example, but query syntax is still very helpful in certain situations. In this particular example, I created both the lion and the tiger and added it to a collection of cats. Then I actually used a LINQ query to select only the cats with the name Simba and made them growl. This is the power of LINQ, which lets you go through the collection and actually find just the ones that you want to act on. In this particular case, you can see Simba has growled. So what happens next after you've written the code? The code that you write in C# is placed in files with a CS extension for C#. In this example, program.cs is the main file that you start with for most C# applications. The .NET Core compiler is called Rozlyn, and its job is to compile the code you write to the Common Intermediate Language, which we referenced earlier. The configuration for how the Rozlyn does this is stored in a file called csproj, which is short for C# project. Over here we can see that we can edit the project file, and this file is called Intro to .NET Core csproj. Rozlyn's job is to read and configure itself based on your CS project file, then interpret the code and compile it to the Common Intermediate Language. In this case, we're targeting .NET Core App 3.1, but this could be a number of targets, including multiple different types of targets. We'll talk about the different targets in another video. The Common Intermediate Language is then packaged in a DLL file, or Dynamic Link Library, or an EXE, which is short for executable. This is then executed by the Common Language Runtime, or just Runtime, on any supported platform. We'll show you the DLLs here, usually found in the bin, and usually a release type debug .NET Core App 3.1. You'll see that we have a DLL file here, along with some of the other dependent files, but the most of the logic here is the DLL and the EXE. Once you've compiled your code into a DLL or EXE, it's ready to run on a runtime. This is referred to by different names, such as CLR, short for Common Language Runtime, or just Runtime. And in fact, on GitHub, it's just .NET/runtime. The .NET Core Runtime supports a number of platforms, including Windows, Linux, and Mac, which we'll talk more about next. The runtime's job is to convert CIL files, DLLs and EXEs, to bytecode that sends instructions to the CPU. The way this has to be done is different on each platform, thus there's a runtime implementation that's independent on each. The two-stage compilation between code and CPU is for a reason. The output is different for each platform, but the input is always the same, the Common Intermediate Language. The Common Intermediate Language is a good abstraction as well, since the Common Intermediate Language can be compiled to with any programming language, like C#, Visual Basic, and F#, and can generate common intermediate language that will then be run in the runtime across all platforms. In our particular example, we have a DLL file which contains the common intermediate language, and we can use a .NET runtime within the .NET CLI to run it. Intro to .NET Core DLL, like this, .NET and then the DLL. The cat with the name Simba has growled. This runs the application. On Windows, in fact, you also have access to the exe by default, which is Intro to .NET Core, like that, and it will do the same thing. This runs within the context of Windows itself, and only for Windows. The final step on our journey is to talk about the .NET Core ecosystem. The .NET Core ecosystem relies heavily on Visual Studio or Visual Studio Code for cross-platform development, NuGet, and GitHub, a core piece of what .NET Core is doing and a recent Microsoft acquisition target. Visual Studio is the primary integrated development environment, which I'm showing here, and for every .NET Core language. It is a Windows-only application, so if you plan to develop .NET Core on Linux or Mac, you'll be using Visual Studio Code instead. Visual Studio and Visual Studio Code both provide all the tools you'll need to get started developing, debugging, building, and deploying applications in .NET Core. We may even cover Visual Studio Code videos here on this channel. NuGet is a package manager where you'll find almost everything you could possibly need to get started with .NET Core. We'll be using NuGet a lot here. In fact, the .NET Core libraries themselves are hosted on NuGet and downloaded in a modular way, allowing developers to build the smallest, most efficient applications possible. You only install the parts of the .NET Core platform that you actually need and ignore the rest. This results in a much smaller, higher performance application overall than the .NET framework, where all the core class libraries needed to be built into the applications and trimmed down later, if necessary. NuGet stores reusable libraries, and you can use libraries and code that other people publish and maintain, or you can even publish your own libraries and maintain those as time goes along, and you'll see probably libraries we build here that we'll maintain over time as well, at no cost to you or others. GitHub is a source control and social site designed to support all developers and many languages, including C#, Visual Basic, and F#. Find many open source projects here of all sizes, personal projects, and even enterprise projects hosted on GitHub. The .NET Foundation projects are hosted here, so you'll find all the source code for .NET Core on GitHub, including the Runtime, Rozlyn compiler, and other .NET Core libraries and applications. Users of the site can download, try, view, and contribute to all the projects on GitHub that are public. The site also allows users to host private repositories, which, obviously, the public cannot see, where other users can't see the code unless you've explicitly shared with them. As an acquisition of Microsoft, GitHub is already and will continue to be more and more integrated into the .NET Core ecosystem in the future, and you'll probably hear a lot more developments in terms of GitHub integration with Visual Studio, .NET Core, and the .NET Foundation projects just in general. Well, that's it for the basics covering .NET Core. Even though .NET Core is a huge topic and has many moving parts, I hope this served as a good starting point for you and prepares you well for a deeper dive on some of these topics, especially the C# videos I'm planning in the near future. Thank you very much for watching, and if you enjoyed the video, please like and subscribe to the channel, and I'll see you again soon.